Okay, so look at the transmitter spurious output now. This is a slightly difficult measurement to make because of the coupler which I'm using, but you'll get the idea anyway. So the radio is set to transmit at I'll just turn the power up to 100 watts here momentarily, 28 megahertz. You see that signal coming up there. The big one here, this one here is the fundamental. Ignore the one on the extreme left, that's the DC marker. And as I turn up the drive power up to 100 watts, there we go, you'll see there's another smaller one pops up to the right there. This one here, which is the second harmonic, and it's just 40 dB down as it should be. The third harmonic we can't actually see at the moment because it's down in the mush, but this specification calls for harmonic suppression of greater than 40 dB, which it clearly is, and I'm sure if I was to tweak up the spectrum analyzer we could see it. Okay, we're going to do the same set of tests on 7 megahertz now. So what I'll do is just quickly change everything to 7.2 megahertz. I think will be a good frequency to go at. Frequency 7.2 megahertz on the spectrum analyzer, and span 10 kilohertz on that, like that. Okay, so I just got to peak the driver on the noise, receiver noise, which is there, about midway. Okay, let's tune it up on relatively low power to start off with. I'll just put the power meter, the scope, the camera I should say, on the power meter across here, so you can see how we're doing for power as I bring it up onto tune. Right, turn on that noise, back off the drive, we're in tune, key up, like that, bring up some drive, I'll just put that back to 7 megahertz, and we'll just peak the PA there. That's just the right setting. Always a little bit fiddly just to bring these things in. Be very careful I don't overdrive it. Ooh, like that. Well, clearly I can easily get 100 watts plus. That was about 120. Let's bring it down to about there. I'll just turn it off for a second, so I don't want to overcook the PAs. 10 seconds maximum, they say, for tuning the PA at maximum power. And I've got the fan running on the background all the time just to make sure. Very important to keep the valves cool. I'll have another little go here. Alright, that's about 100 watts output for 250 milliamps of cathode current. So what we'll do here now, we'll just go to the scope. We'll set the scope up so it's full scale at 100 watts output. I'm sure we'll try to get that thing focused on there. Let's turn that intensity down a bit. Always difficult to get the lighting and stuff just right, isn't it? Particularly when you're doing everything yourself. Alright, turn up the intensity a bit. This is 100 watts and I want to adjust the scope so we just get full scale. When we key up here. Okay, so 100 watts. quickly bring that up, bring that. So that's 100 watts, and it's not quite filling the screen. Okay, we'll go to tune. Transmit. Let's put some audio in, shall we? Like that. Bring up the mic gain, and we know that's compressing now, so round about there is 100 watts PEP output, and the intermodulation distortion on the spectrum analyzer is shown over here. I'll zoom in just a little bit more if I can. These are the two tones, 800 Hz, 1.8 kHz, and you can see that the intermodulation distortion is a good 35 dB or so down. So it's actually very good intermodulation distortion at 7.2 megahertz. And the power output meter, if it would focus, is showing the average power of just under 50 watts, around about 45 watts or so. But that's for a very nice clean 100 watts PEP output on the scope there. Now let's just have a quick look at the harmonics here. So I'll put the analyzer there on display, and quickly, so I'll just turn it off for a moment to give the PAs a bit of time to cool down while I adjust the settings on here. So at the moment we're looking at 7.2 megahertz with a span of 10 kilohertz. So now what I want to do is to just increase the span up to something more usable. Let's go DC to 100 megahertz. So I'll put frequency center in the middle, 50 megahertz like that. So we're going from DC now here to 100 megahertz. So 7 megahertz should come up just, so that's basically 10 megahertz per division. So 7 megahertz will come up right up close on the left hand side here. Then we'll see all the harmonics thereafter. Okay, let's key up the radio. Like that. And you can just about see the second harmonic there. This is with two-tone testing, which is why it's jiggling up and down a bit. But you can see that the second harmonic is at least 50 dB down, so harmonic power is really well within specification there as well. And the last thing I should perhaps show you is when I was putting in these new tubes, just disconnect the audio, I was making sure that the bias current was set for 50 milliamps. Let's just see if that shifted at all. We get to focus on that. Meter's set to read cathode current. We'll just key the radio, and sure enough the cathode current's just a nice 50 milliamps where it should be. And I've noticed while I was tuning this radio, as I dip the cathode current, that corresponds quite nicely with maximum power output. So we'll just do that one more time here. You'll see what the cathode current's doing. I'm not sure I can get them both in the same shot actually. We'll just see here if we can. No, not really possible from this angle. So we'll just go into tune mode, and we'll just dip the PA current. Yeah, and it corresponds exactly with maximum power output, which is just right. Okay. So there you have it, a very brief run through of PA neutralization, setting the bias current to 50 milliamps, and checking the intermodulation distortion on a couple of bands, and harmonic output power. Harmonic output power is well within specification. The IMD's okay on 10 meters, but actually quite good down on 40 meters. And I'll just do the rest of the bands check them through. So it's looking good. That's all for now.